Welcome back, fourth graders. Today we're going to be doing some division with interpreting remainders, which is just a fancy way of saying we're going to divide, and then once we have a remainder, we're going to decide what that really means. So I'm going to work through these two problems with you, and then I have a few example problems you can work with on your own. So let's get started. There are 139 students and 13 adults going on a field trip. I always ask my kids to stop here and really visualize what that looks like. We picture the parents standing with us and all of the kids and where the bus would be picking us up, or in this case, it looks like it's going to be a van, but I always ask my kids to stop and get the picture in their head. So do you see 139 students and 13 adults standing together ready for a field trip? I do, and I see them maybe going to the zoo. The vans that they're going to take, so they're taking vans, like I said, instead of buses, so I got to build another picture in my head, and those vans only hold 9 people. What's the least amount of vans they will have to take in order to make sure everyone gets it to the field trip? Looks like I made a little spelling error. To the field trip. So first, like I said, I imagine the 139 students and the 13 adults. So if I put those two numbers together, 139 and 13, I need to figure out how many people total are going on the field trip. Well, 9 and 1 is 10, so 9 and 3 must be 12. 3 plus 2, which I see that is 2, is 5. So 152 people must be going on the field trip. And the vans they're taking only hold 9 people. So we talk in my class that division, which is what I'm going to do here, is just repeated subtraction, which makes sense. If I had 152 people, as the teacher, I'd say 9 of you get into this van, and 9 of you get into this van, and 9 of you get into this van, which is just repeated subtraction, which in the long run is long division. So I have my 152 people going on the field trip, and I'm going to divide it by 9 because that's how many people can fit into a van. In my class, we use Hangman Division. If that is not a strategy that you use in your class, you can use anything else that you want. You can pause this video and solve it on your own for a challenge. Or if you've never used Hangman Division, you can sit and learn with me now. I will go through it step by step. So it's basically just like multiplication. I'm going to multiply to see how many times 9 can fit into 152. I know that 9 times nothing gets me 1. So then I need to push it to 15. And I think 9 times what gets me close to 15? Well, 9 times 1 is, 9. But I need 9 times 10, which is 90, because it's really close to 152. So I'm going to subtract those. 2 minus 0 is 2. And then in my class, we don't really borrow when it comes to this. We just say 15 minus 9. 9, 10, 11, 12, 13, 14, 15, which is 6. And then I think about my multiples of 9. 9 times what gets me close to 62. I know that 9 times 6 is 54, and 9 times 7 is 63, which is a little bit too big. So I'm going to have to say 9 times 6 is 54, and make that a 12, and make that a 5. 12 minus 4 is 8. And I know that 9 times nothing is 8, so he must be a remainder. So I add these two together to get 16, remainder 8. In my class, we don't write remainders like that anymore. Now that we've talked about fractions, we write that I have 16, and I had 8 left over out of the 9. That's easier for me to answer this question when I write it this way, because I go back and they say, what is the least amount of vans that they're going to have to take? Well, if I have 152 people and I keep putting 9 people into a van, it looks like I'm going to need 16 vans, but then that leaves 8 people standing without a van to ride in, which means they wouldn't be able to make it to the field trip. And we talk about in my class how rude that is. We can't leave them behind. And so instead of having 16 vans, we're going to have 17 vans. The only difference here is that that last van, instead of being full, will only have 8 people. So think about how many more people I could invite to the field trip in order to fill that last bus. And that's why writing this fraction like this helps, because you can see I only need 1 more ninth to equal a whole. So if I invite 1 more person, then that last 17th van will be full. But either way, whether I invite 152 or 153 people, I'm going to need 17 vans because I'm not going to leave those 8 people behind. Let's look at the next one. Amelia and Matt are planning a wedding. There are 367 guests that are coming to their wedding, and only 8 guests can fit at each table. How many tables will Amelia and Matt need to rent in order to accommodate all of their guests? So again, I asked my kids to build that picture. I imagine wedding tables as a round table, and maybe 4 people sit this way, and 4 people sit that way, and there's my 8 guests. So that's in my head what my tables are looking like. So there's 367 guests, and they're sitting at tables of 8. So I need to figure out how many tables I need. And we're going to use Hangman Division again. So 8 times nothing is 3. So I'm going to push it to 36. So I think in my head, 8 times what gets me the closest to 36? Well, I know that 8 times 4 is 32. But I don't need 32. I need 320, which means that 8 times 40 is 320. I bring down my 7. I know that 6 minus 2 is 4. And then I do some more thinking. I know that 8 times 5 is 40, which is pretty close. 8 times 6 is 48, and that's a little bit too big. So I'm going to need to do 8 times 5, which is 40, which leaves me with 7. I know that 8 times nothing is 7 because he's too small. So I'm going to find my answer, which is 45, and my remainder is 7. But like I said in my class, we write ours as 45 and 7 over 8. So if I look back, how many tables will they need to rent? Well, if I have 360 people, 8 people can sit at each table. That would be 45 tables, but then I'd have 7 guests without a table. So even though they won't fill a table, instead of having 45 tables and 7 people without a table, I'm going to go ahead and have 46 tables. Just like we did before, when I needed just 1/9 of a person to make that last van full. This is 17 vans, but they're not all full. How many more wedding guests could I invite to my wedding to make sure that that last 46th table is full? Yep, it's also just going to be 1 more person, because all I need is 1 more 8th to equal 8/8 here, which would then turn me into 46. So if I invited 368 guests to my wedding, then all 46 tables would be completely full. You're going to get to have a chance to do some of your own work. So here's some extra practice. There's just 2 problems, and I've given you some questions to answer about those problems. So the first one, Susie has 104 stickers. Get the picture in your brain. What do her stickers look like? And she wants to split them equally amongst her 5 friends. She's going to take all of her stickers, and she sees 5 friends in front of her. I always picture this as like handing out cards, just one at a time, all of your stickers to your 5 friends. And anything that she has extra, which would be the remainder, she's going to give to her brother. So the first thing you're going to need to do here is 104 divided by 5. And then think how many stickers does each of her friend gets. And then how many does her brother get? Number 2, Joshua bakes 87 cookies, and he splits them equally between himself and his 3 friends. And he gives all the extra cookies to his mom. So again, we're going to need to divide 87. And this one is a little bit tricky. Think about the words he splits them equally between himself and his 3 friends. So yeah, that's actually divided by 4, not 3, because he's going to give some to himself. So 87 divided by 4. Make sure you do that work. And then how many cookies will each of them get? And how many cookies is he going to give to his mom? If you get the chance, there's some bonus at the bottom. Just like we did before, when you finish Susie's stickers, think about how many stickers she could add to her collection in order to make sure there's no leftovers, which means her brother wouldn't get any that time. And then the same with Joshua. How many more cookies could Joshua make where he would have no extras that he would have to give to his mom, but all of it could be split equally? So take a second, pause this video, do the division problems for both number 1 and number 2, and figure out exactly what your remainder means, how many Susie's brother would get, and how many cookies Joshua's mother would get. And now we're going to talk answers. Okay, so just like I said with Susie's stickers, you're going to do 104 divided by 5. And when I did that, I got 20. And then my leftover was 4. So every friend would get 20 cookies, and Susie would have 4 cookies left over. But we know what Susie's going to do with her leftover. Oh, she doesn't have cookies, does she? She has stickers. My kids will not be surprised that I've messed this up. Stickers. It's Joshua that has the cookies. Okay, so each friend would get 20 stickers, and Susie's going to have 4 stickers left over, which means her brother gets 4 stickers. Josh has 87 cookies and splits them between himself and his 3 friends, which would be 4 instead of 3. So if I do 87 divided by 4, I would get 21. and a leftover of 3. So every person would get 21 cookies, and I'd have 3 cookies left over. And the 3 cookies would go to Josh's mom. So now think about the bonus. On this one, everybody got 20 stickers, and then there was 4 left over out of the 5 that we had. So if Susie just added 1 more sticker to her collection, this would become 5/5, which would make this all 21 stickers for each friend. And unfortunately, her brother wouldn't get any. Let's look at Josh's. When I do 87 divided by 4, it's 21. And the remainder is 3 out of the 4 friends he was splitting it between. If he just added 1 more cookie, this would now be 4/4, which is a whole, and 21 plus a whole is 22. So each friend would get 22 cookies. Try making your own division problems and see if you can find any remainders, and then make up some word problems in your head. It's really easy to do at home. You can do it when you think about pizza or dinner or your card collection, anything to continue your learning for math at home. We're really proud of you for continuing to work at home, and we miss you every single day.